Good morning. In the lesson today, we're going to review engineering notation. You can see that across the top of the page, I've included a chart containing the most common engineering prefixes. So for this course, we're going to consider the prefixes between giga, or 10 to the power of 9, and pico, or 10 to the negative 12. Many of the prefixes have exponents that are multiples of 3, and these would include giga, mega, kilo, milli, micro, nano, and pico. But I've also included in here the prefixes for 10 squared, 10 to the 1, 10 to the negative 1, and 10 to the negative 2. Here, with an exponent of 0, we would have the basic unit with no prefix. Okay, here are the 3 things we'd like to do. First, we'd like to write each quantity without a prefix. So here's our first example. If we have 12.8 kilowatts, we use the chart to determine that this is the same as 12.8 times 10 cubed watts. And from there, we can eliminate the power by simply moving the exponent 3 places to the right. So this will be 12,800 watts. Here's a second example, 108 centimeters. In the chart, we replace centi with 10 to the negative 2. So we have 108 times 10 to the negative 2 meters. This exponent telling me now to move the decimal 2 places to the left. In the whole number, of course, the decimal would be located at the end. So if we move it to the left, we will have 1.08 meters. Okay, one more example. This is the Greek letter mu. So we are here in the chart, micro. So we have 8,450 times 10 to the negative 6 seconds. Move the decimal 6 places to the left. The decimal currently is here at the end of the number. So after moving it 6 places to the left, we would have 0.00845 seconds. Don't put a 0 here after the 5 because that trailing 0 would then be significant and you would be increasing the accuracy. Since the original number contains only 3 significant digits, we want to maintain 3 significant digits here as well. Okay, so that was the first objective. The second thing we should be able to do is convert from one quantity to another, rather one prefix to another. So in this first example, we are going from nano to milli. So we use the chart to help us. Nano is here in the chart, 10 to the negative 9, and milli is here in the chart, 10 to the negative 3. From nano to milli, we are moving left. So that is in effect what we're going to be doing with the decimal. We're going to be moving it left. How many places? From negative 9 to negative 3, this is 6 places. So what we have is 125 times 10 to the negative 6 millifarads. Or, now actually go ahead and move the decimal 6 to the left. So from the end of the number, 6 to the left would look like this. 0.000125, and that would be millifarads. Okay, here's another one. From kilo to deci. Kilo to deci. The unit is meters. So here's kilo in the chart. Here's deci in the chart. From kilo to deci, moving to the right. How many places? From 3 to -1, that's 4 places. 1, 2, 3, 4. So we're going to be moving the decimal 4 places to the right. So this means we have 3.24 times 10 to the 4 decimeters. Now go ahead and actually move the decimal 4 to the right, and we would get this. 32,400 decimeters. Okay, here's another one. From hecto to here, there is no prefix. The unit is newtons. So we're actually going from hecto to no prefix here in the chart. From hecto to no prefix. This is to the right 2 places. So we have 0.52 times 10 squared newtons. Now let's move the decimal 2 to the right. We'll end up with 52 newtons. Last one, the unit is joules. We're going from mega to deca, D-A, deca, mega to deca. Mega is here, deca is here. The motion will be to the right, so the decimal will move to the right. How many places? From 6 to 1, that's 5 places. You can count like this, 1, 2, 3, 4, 5 to the right. So we have 2.1 times 10 to the 5 deca joules, or now we move the decimal 5 to the right. So this means we'll have 4 zeros in front of the 1 and the 2. So we get 210,000 deca joules, like that. Okay, the last thing we need to be able to do, take a quantity in ordinary notation and then choose the most suitable engineering prefix. Okay, the instruction says, write in engineering notation with the decimal after the first non-zero digit or one of the 2 following digits. Okay, so here we go, 2,400,000 hertz. So the decimal currently is here. So we're starting here with no prefix. If we move 3 to the left, we haven't satisfied the instruction. There would be 4 numbers still to the left of the decimal. So we move 3 more places. So this will be 2.4 times 10 to the 6 hertz. 3, 6. And then look up 10 to the 6 in the chart, and it is mega. So we end up with 2.4 megahertz. Let's try this one. If we only move 3 to the right, we would not satisfy the instruction. If we move 6 to the right, we would not satisfy the instruction because there would still be nothing but 0 out front. So we have to move 3, 6, 9 to the right. So that means this would be 450 times 10 to the -9 henries. 3, 6, 9. So we need a 0. 450 times 10 to the -9 henries. And then simply look up -9 in the chart, and it is nano. So we end up with 450 nanohenries. Part C. If we move only 1 to the right, not good enough, we'll have 0 out front. 2 to the right, not good enough, we'll have 0 out front. But 3 to the right will satisfy the instruction. So moving 3 to the right will give us 6.0 times 10 to the negative 3 amps. Notice this 0 is included because the original number has 2 significant digits. We want to make sure we have 2 significant digits here as well. Now replace 10 to the negative 3 with the prefix milli, 6.0 milliamps. Okay, we're going to do 3 more examples which begin in scientific notation. Okay, so example D, 6.4 times 10 to the 8 watts. Now, the problem, of course, is that 8 is not one of the powers for which we have a prefix. 8 would be right here in the chart. So we have to change the exponent such that it corresponds to one of the prefixes. So obviously it's closest to giga and mega. In fact, what you do is always go to the lower one. So giga would be a higher exponent. What we're going to do is go to the lower one, mega. If you go to the higher one, you'd end up having to move the decimal to the left. And that would not be good because then we'd have 0.64, which would not satisfy the instruction. So we have to go to the lower exponent of 6. So we're going to make this times 10 to the 6 watts. Now in doing so, of course, we just lost a factor of 100. So that means this number out front has to be multiplied by 100. So 6.4 times 10 to the 8 watts is the same as 640 times 10 to the 6 watts, or 640 megawatts. Okay? It's also equal to 0.64 gigawatts, but again, we don't want a 0 out front because of the instruction. All right, so here's another one, negative 8. Of course, negative 8 is not in the chart. Negative 8 would be right here in the chart. Now remember the rule. The rule is to go to a smaller exponent. So negative 8 is here. In comparing negative 6 and negative 9, which is smaller? In fact, negative 9 is smaller than negative 8. So we want to change this to negative 9. Okay, so when we drop that to negative 9, we just lost a factor of 10. So we have to adjust the number out front by multiplying it by 10. So we now have 12.5 times 10 to the negative 9 farads, or 12.5 nanofarads in our final answer. Here's one more. 2.75 times 10 to the negative 11 seconds. Negative 11 would be right here in the chart. The closest prefixes are nano and pico. From negative 11, though, the smaller number is negative 12. So that is the one we select here. If we go from negative 11 to negative 12, we have just lost a factor of 10. So we have to compensate by multiplying the number out front by 10, or moving the decimal one place to the right. So this becomes 27.5 times 10 to the negative 12 seconds, or 27.5 picoseconds. Okay, so those are the 3 objectives for today's lesson. Being able to use the engineering prefix chart that I created for this course, to carry out the 3 types of practice problems we've just completed together. So if you now go into the Module 1 folder of Blackboard, you will find this document. It says practice exercises, and there are many here for you to complete. In addition, included in the document, you'll find the final answers for these practice problems. Okay, so that's all for today's lesson. Please do take the time to go through the questions posted for you. Thanks and have a great day.